Centre of mass introduction. This video is going to look at an introduction into finding the centre of mass of a set of particles on either a straight line or a plane. In Mechanics 2 we're going to look at questions to do with finding the centre of mass of laminas, which we introduced the concept of laminas in Mechanics 1. Now the equation that we're going to use to find the centre of mass for a set of particles arranged along a straight line is shown here. It is the sum of all the masses times the distance, which is equal to the centre of mass times by the sum of all of the masses added together. So the new terminology here is we have this x with a line above it, and that indicates the centre of mass. Now if we look at an example, hopefully you'll see where this equation comes from. Find the centre of mass of three particles of masses 2 kilograms, 5 kilograms and 3 kilograms, which lie on the x-axis at the points 3, 0, 4, 0 and 6, 0 respectively. So if we plot these points along a straight line, along the x-axis, so we've got the x-axis here, and we're starting from the origin, 0, and our first particle of mass 2 kilograms is at the coordinate position 3, 0. So here we've got our 2 kilograms acting downwards, which is going to be acting under gravity because it is going to be the weight. We've also got another particle, 5 kilograms at 4, 0. So 5g, and finally we've got our last particle of mass 3 kilograms, which is a weight of 3g, which is at the coordinate position 6, 0. So if we label each of the positions above, I'm not going to put the 0y component because we know that we're looking along the x-axis. So this is a distance of 3 from 0, this is a distance of 4, and this one is a distance of 6. And what we're asked to do is to find the centre of mass of these three particles. So what we're going to have is along our x-axis, we're going to have some position here where all those masses will be acting. Let's call this mass at the centre of mass G. So this is where these three particles will all be having their centre of mass. Now if we combine these three weights that we've got here, 2g, 5g and 3g, we get a total of 10g acting downwards. Now if we look at the formula we're given, we've got the sum of all the masses I times the distance I is equal to the centre of mass times the sum of all the mi's. So let's use this equation to find out where the centre of mass is. So we've got this equation, mi xi is equal to x slash sum of the mi's. So the distance between the first particle and the x and the 0 is 3, and we're timesing it by its weight. So 3 times by 2g. The next one was 4 times 5g. And finally we had 3g times 6. And on our other side of our equation we've got the centre of mass times by the sum of all of our masses, which was 10g. Now what you should notice here is that all these components have a g part, so we can cancel them all out. And I suspect some of you have been wondering so far why I've been saying mass here and yet we put the weight in here. It's because in all the problems we're going to come across, you're always going to have the gravity involved, which is going to cancel out from all parts. But that's why in the equation we have masses rather than the weight, because the g's will always cancel out, because we could, if we wanted to in the equation here, have added a g here and a g here, but then they would have cancelled out, so there'd have been no point. Now basically all we need to do is tidy up the left and the right hand side, and we'll be left with a little equation to solve. So 3 times 2 is 6, 4 times 5 is 20, 6 times 3 is 18, and on the other side we're left with 10 times the centre of mass. Add up the parts on the left hand side and you get 44, and that is equal to 10 times the centre of mass. And then obviously the centre of mass, divide both sides by 10, we're going to have a centre of mass of 4.4. Now what this means is that this centre of mass is 4.4 away from our origin, which is what we really need to identify each time. So it's actually a coordinate of 4.40 because we're looking on the x-axis. Now this could also be done exactly the same way with using the y-axis, but instead of using x with a line over top, we'd use y. So this represents the centre of mass. Now that is a very simple question, looking at finding the centre of mass along a straight line. But the rule we've used here is we're going to get very, very used to using. And now we're going to try and apply it, this time on a plane. So it says you can use the sum mixi equals x over, with a line over top, times the sum of mi's, and the sum of mi's yi is equal to the centre of mass, the y with line over top, times by the sum of all the masses to find the centre of mass of a set of particles arranged in a plane. Now all this second equation is just the same as the first equation as just mentioned, but this time the coordinates are on the y axis rather than on the x axis. Now what you'd be advised to do is draw a quick diagram possibly to help with these questions. You don't always, but sometimes it helps. 3 particles of mass 2 kilograms, 1 kilogram and m kilograms are situated at points 1, 3, 2, 9 and 2 to the minus 1 respectively. Given that the centre of mass of the 3 particles is at a point 1, y with a dash over top, find the value of m and find the value of y with the line over top. Now this question doesn't really require a diagram. The kind of questions which would require a diagram are ones where you might be told that the points on a rectangular plane, and you might be given 4 coordinates, and that would be a really good situation to draw a quick diagram to help you. Now, what we're going to do is we're actually going to combine these two equations. So we've got remember we're always doing our weight, which would be 2g, times by our position away from the origin. But here we've got our mass, so 2g, that would be our weight, because it's 2, the mass times the force of gravity, is at the vector minus 1, 3. 1g is at the vector 2, 9. mg is at the vector 2, minus 1. And this is equal to the sum of all of the masses. So that would be 2g add 1g add mg, so that would be 3g add mg. 3g add mg times by 1, because we know the centre of the x is 1 and y dash. Now if we simplify this a little bit, remember you should notice that each part has a g, so we don't need to keep that in, and on the next video we won't be showing the g's because we'll just be looking at the mass. I was just indicating the weights again to show you why we don't have the g in the equation. If we multiply the 2 into the vector, we're going to have minus 2, 6 and 2, 9 and 2m minus m, and that's going to be equal to, if we multiply in the 3 and the m into this, we're going to have 3 plus m, and then 3 plus m times by centre of mass for y. So, if we tidy up the left hand side as much as we can, we're going to have minus 2 and minus 2, which is 0, which just leaves us with 2m on the top for the x part, and for the y part, we're going to have 6 plus 9, which is 15 minus m, and that is equal to the 3 plus m and the 3 plus m times by the centre of mass for the y. So, if we want to find the y, we can, the m part, we can use the top x parts first and set them equal to each other. So looking at the x, we've got 2m is equal to 3 plus m. So take away m from both sides, we've got m equals 3. Now we can use that to find out what the centre of mass for the y is. So looking at y, we're now going to have 15 minus m is equal to 3 plus m times the y, centre of mass. Well, we know that m is now 3, so 15 minus 3 equals 3 plus 3 times by the centre of mass for y. Well, 15 minus 3 is 12, 3 plus 3 is 6, so it's y 6. So this means overall that the centre of mass for these three particles, well, we already knew the x part was 1, well, we now know the y component is 6. So this is more like an exam style question. You get very, very used to this situation. Remember, in this video we've talked about the weight rather than the mass, but the reason we don't need to talk about the weight, we can just talk about the mass, is because the g's will always cancel out from each part of the equation. So the equations you need to know are these two equations here, and you're going to use these a hell of a lot in the centre of mass topics.